I'm Sion. I'm Alex.
I'm Angela.
I'm Adrian. I'm Wu.
I'm Shirling.
We are from Group 29.
It might seem crazy what I'm about to say.
Hello.
I'm a hot air balloon that could go to space with the air like I don't care, baby, by the way.
Hi,
we are the Android team.
I'm Lemin.
And I'm Adrian. We are the developers for Group 29 MDP Android app. So without further ado, let us show you the functionality of our application.
For the Android part, this is how it will look like in the tablet. We will first intro the function of this app and do a demo thereafter. The bar here will show the Bluetooth connection status. S1, S2 button will send the custom predefined string to the Raspberry Pi. The spanner icon allows the user to set the string for both S1 and S2. The arrow here are the direction button. At the bottom, we have our toggling mode. By default, it is on manual mode. Start, update and stop button will be grayed out when it is switched to auto mode. On the right side shows the check log of string you have sent and received. On the above shows the current status of the robot. Robot will start on the top left corner, red indicating the direction it is facing. The robot can only move within the boundary. Green boxes represent obstacles. The robot endpoint will be at the bottom right corner.
I'm Angela.
I'm Alex.
And together we are the
Raspberry
Pi
team. We will elaborate about the exploration and how the Raspberry Pi works. And let's go!
So for our exploration, we are using the breadth-first search algorithm. As you can see, there's an animation showing you how the breadth-first search works. The breadth-first search begins at the root node, which is node A in this case, and inspect all of its neighboring nodes. Node A's neighboring node is node B and C. Then for each of its neighboring nodes in turn, it inspects their neighbor nodes which were unvisited. The process will continue until all the nodes in the trees are visited. So for exploration, if the robot sensor scans that there's an obstacle in front of the robot, it will turn right, otherwise if there's no obstacle, it will continue to move forward. The breadth-first search traversal of the maze will step through all the paths at the same time until it reaches the goal.
Here's a diagram to show you how our system is connected with the Pi as the middleman, taking in values and passing it around to Nexus 7 via Bluetooth, Arduino via Serialcom and PC via Wi-Fi. Pi will provide Arduino with commands to robot and also take in sensor values from Arduino for the exploration algorithm. Here's an example. Next, Pi will provide Nexus 7 with the coordinates of the obstacles and take in commands from Nexus like up, left and right. Here's an example of the coordinates that Pi will send to Nexus 7. And lastly, Pi will provide PC with coordinates of obstacles and take in the next move command from the maze traversal algorithm. Here's an example of Pi sending PC a series of obstacles coordinates.
Hi, I'm Wei-Zhen. I'm in charge of Arduino board.
For Arduino part, in our project we use Arduino Uno board. So this is Arduino Uno board. But we also need to use Arduino motor share boards control two DC motors by using PWM. So this is Arduino motor share board and this is a DC motor. So after we combine all the hardware components together, we need to get the motor encoder's value. This encoder's value can be used to calculate the distance robot moved. Then after that, PID control can use the encoder values to help robot vertical straight line. So the last part is a sharp IR sensor. Based on the voltage to distance chart, we can write this kind of C language code to get the distance to reflective object, which can help algorithm to make a decision. That's all for this part.
I'm Shannon.
And we are the software team. And now we will show you how did we do our simulator.
The simulator tries to replicate the actual functions on the robot as close as possible by providing simulation for both obstacle detection and action networking, as well as giving appropriate feedback whenever the robot has hit an obstacle or reached the start of goal, and displaying the time as well. The green area actually depicts the current sensor range on the robot, and we calculate that by comparing the robot current distance to the wall and taking whichever is lower value, either the maximum sensor range or the distance to the wall. And as for the arc in the front, this is actually because of the rotating sensor. So we had to compute the distance by bilateral stereo using hypotenuse and actually following or sealing the answer to get the range and fit into the grid. Okay, the scanning is done via 3 loops. First a for loop, which is red and blue color, to actually move the range scanning forward, and the red and the orange arrows are actually the scanning of the rows or columns depending on orientation of the robot.
Oh no. Oh no. Take now. But in terms of the time, it's about 1 minute and 3 seconds.
Okay, Ken. We accept that.
What algorithm do you use? One, action.
Hi, I'm Stephanie.
I'm Angela.
I'm Alex.
And we are the...
We are the software team. And now we will show you how we do our simulation. How did we do our simulation? Can